Hi everyone, welcome back. Today I'm going to cover some basic operations in Arena, and I'm going to do this by building a modified version of Model 4-1 from the textbook. Now, the description of the modified model is in the lab handout on Carmen, but if you're following along with the textbook, you'll notice just a few differences, mainly that I've also included the times it takes for parts to move through the system. The original Model 4-1 doesn't include any travel times. So the system we are modeling is an electronic assembly and test system of two types of electronic housing units, Part A and Part B. These parts are sent to their respective prep stations and then are sent to a sealer machine. After leaving the sealer machine, the parts are inspected, and if they are good, they get sent off for shipping. If they are no good, they get sent to the rework station. After they've been reworked, they are inspected again. If they're good, they get sent off for shipping, and if they're still no good, then they get sent off to scrap. So the first thing that we're going to do is we're going to add a create module because we have parts arriving. And let's call this Part A arrives. The entity that's arriving is Part A. And the time between arrivals, the inter-arrival time. And we can do the same thing for Part B. And now just to show you a couple different ways to edit in Arena, I'm going to make the changes down here instead of in the dialog box. So this is going to be Part B arrives. The entity is Part B. Again, it's an exponential distribution with a mean of 30 minutes. And this time, Part B arrives in batches of 4. There's no limit on the number of arrivals, and the first creation is at time t equals 0. And now that we've added these two create modules and named the entities that they create, if we go to this entity spreadsheet, we'll see that these entities have been automatically created here in Arena. So that's nice. And we'll just make a very simple change. Instead of having these be the same picture, let's make the Part A a green ball and Part B a red ball. Okay. And then after after these parts have arrived, Part A is transferred to the Part A prep station, and it takes 2 minutes to travel to the Part A prep station. And there are more sophisticated ways to model transfer times in Arena, but for now, we're just going to do something very simple. We're just going to show that some time has passed. So we just represent this travel time with a delay module. This is in the advanced process template. And if you don't see this template, you can just go to File, Template Panel, Attach, or click this button on the toolbar and you will see all of the templates right here. So let me add this delay, and we'll call this to Part A prep. This is a transfer. The delay time is 2 minutes. Okay, and I'm just going to copy and paste this down here. This is to Part B prep, still a transfer, and we're told that this travel time is distributed according to an exponential distribution with a mean of 2 minutes. So we say this is an exponential distribution with a mean of 2 minutes. Okay, and then they are transferred to their respective prep stations. So let's create a workstation here. We can call this Part A Prep Workstation, WS. This is a seize delay release. Usually when we're modeling basic workstations, there are resources that are used when the process is running and the same resources are not used when the process is not running. So this process needs a resource. Let's add this here, and we can give this resource a name. Call this Part A Prep Operator. Okay. And so with this seize delay release, this means that when an entity arrives in this process, the entity is going to seize this list of resources. there will be a delay, and then after a delay, the resources will be released for other entities to use. So this delay is the process time, which is distributed according to a triangular distribution with a minimum of 1, a mode of 4, and a maximum of 8 minutes. Check these. Units, okay. And we can duplicate this for part B. This is the part B prep workstation, seize delay release. It's seizing a part B prep operator. Again, this is a triangular distribution, but this time the parameters are 3, 5, and 10. Okay. And then we're told that the parts are transferred to the sealer machine. So let's add 2 more delays. There's a delay here and a delay here. We'll call this A to sealer, and we'll call this B to sealer. These are both transfers. And the delay time here is a triangular distribution with a minimum of, this one is a uniform distribution with a minimum of 1, a maximum of 3. And this is a triangular distribution with a minimum of 1, a mode of 1.5, and a maximum of 3.5. The units are minutes. And if you're paying attention, you might notice that all of these travel times have a mean travel time of 2 minutes, but they're just all modeled in a slightly different way. So later on, when we animate this model, we will be able to see the parts moving through our system, and hopefully we'll be able to see how these different distributions can have an impact on the way our system evolves. So from here, we go to a sealer workstation. So this is the sealer workstation. Again, this is a seize delay release. We have 2 resources here. We have the sealer machine, and we have the sealer machine operator. And we're told that this sealer has a process time that is dependent on the part type. So if we were doing this in a programming language, we would probably try to use like an if-else type logic, like if it's part A, then pull from this distribution. If it's part B, pull from a different distribution. But in Arena, it's pretty simple. We're just going to give this a name. We're just going to call this sealer process time. This is in minutes, okay? And then before we get to the sealer, we just need to define what the sealer process time is for part A and sealer process time is for part B. So let's put in this assign module, and I'm going to call this assign A attributes. And I'm going to put an attribute called sealer process time, and we have to be careful that we spell this the same way it was defined in our sealer process. And the value here is a triangular distribution, 1, 3, 4. Okay, so what this does is for every entity that passes through this assign module, it will have this attribute attached to it. And this attribute will take a value that's pulled from this distribution, and the attribute name will be sealer process time. And so this attribute is a little packet of information that follows this entity around it. It's an entity-specific variable. You can think of it that way. So if we say OK, so now when the part A comes through this assign module, it gets assigned this attribute, sealer process time, and then when it comes to the sealer process, it has the same sealer process time. And so we can do this again now for part B. And the attribute sealer process time for part B is being pulled from a Weibull distribution, we're told. So let's check out the ARENA formula for that. And it's a Weibull distribution with a beta parameter of 2.5 and an alpha parameter of 5.3. And this is just a different distribution, probably one that we haven't encountered, but it's one that ARENA has built in, so we can use it. Okay. And let's just take a minute to connect everything up now. So I'm just going to double click on this connect tool so that the tool stays active, and I'll just go through and I'll connect all of these nodes. Okay, and so then once our parts leave the sealer process, they are inspected, and 91% of the parts pass inspection. So right here, we're going to put a decide module, and we're going to say that this is a question pass inspection. This is a two-way by chance, and 91% pass. And 91% pass and go straight to shipping. Now you want to be careful that the number that you put in here, %true, this is the number that's going to come out. This is very small text, but if you zoom in, it says this is the true node and this is the false node. So 91% go to shipping. Of the 9% that fail inspection, they are sent to a rework process. Rework workstation. This again is a seize delay release. And we're told that there are 2 rework operators, or rework technicians, here, but we want to be careful not to put the number 2 in here, because if we read this label, it says that this is the units, the number of units to seize and release. So if we put the number 2 here, what that would mean is for every part that comes to the rework station, that part needs 2 rework technicians to work on it, and that's actually not the case. So this rework technician takes an exponentially distributed amount of time to fix this part. It is on average 45 minutes. This is non-value added work because we're doing rework, okay? And then after leaving the rework process, we have another inspection. After which 80% pass and go to shipping. And the remaining 20% are sent to scrap. Now, the one thing that we didn't do is we haven't indicated that there are 2 rework technicians. And so we don't do that in this process. What we do is we go to the resource tab, and where it says this process or this resource rework technician, we change this to a capacity of 2. So now we have 2 available rework technicians to work on this process. So this is our model. We're also told that the simulation must run for 4 consecutive shifts. So let's go. We can give this project a name. Let's call it model 4.1. You can't use a dash here because it won't read anything after the dash. So it'll just say model 4. So this is just the project title, and we can go to our replication parameters. For now, we'll just do 1 replication because we want to troubleshoot. Our replication length is for 4 consecutive 8-hour shifts. So let's just do this for 32 hours. And then we want to measure everything in minutes. Everything we were given, all of our process times, everything was in minutes. So it's easiest to look at the metrics in minutes. Okay. And then let's just zoom out a little bit. I'm going to use this magnifying button to zoom in here, and we can just hit play. And so we see our parts moving through our system, and we can see down here in the status bar, this is the amount of time that's elapsed, and we'll just speed this up a little bit because we've got a ways to go. Okay, and yes, let's look at the results. So we were told that we have some certain metrics of interest. We have some performance metrics. We want to know the resource utilization, and so that's given here. We want to know the average number in each queue, so we can see that here. We want to know the average time in each queue, and we want to know the average time in system for parts on their first time through, average time in system for parts that were salvaged, and the average time spent in system of the parts that are scrapped. But if we go to our entities, we only have a breakdown by entity type. We don't have a breakdown by this branch logic. So what we need to do is we need to create our own statistics, not statistics that are in the default reports. We need to create our own statistics. And so we want to measure the time from when each entity arrives to when each entity leaves. So since we are looking at entity-specific variables, entity-specific information, we know we're going to use an assign module to assign an attribute. Now, earlier I put these assign modules directly before the sealer process, but they don't have to be here. They can just be anywhere before we get to the sealer. So let me just cut these and paste them a little bit sooner in the process. Put this right when the parts arrive, and let me link everything back up. And that way I can reuse these assign modules and just add another assignment. Again, this is an attribute. This is entity-specific information. And let me just call this attribute arrival time. And I'm going to give it the current simulation time. So I can come here to date and time functions and look at the current simulation time. And the expression for that is t now. Okay. And I can do the same thing in the assign B attributes. This is again an attribute. If I go on this drop-down list, I have a bunch of attributes that are built in, and I also have any attributes that I had previously defined. So I have this arrival time, and I know that this is t now. Okay, so now we have this attribute that gets assigned right when the part arrives, and we just want to make note of it right before the part leaves. So we're going to do this with a record module. We can add these record modules right before these parts leave. So let's call this record first time through stats. And let's add a statistic definition. First of all, let's count the number of parts that are exiting. So we can call this number first time through. Okay. And then we can also find the time interval between the attribute called arrival time and when the entity enters into this record module. And let's save this into a tally called first time through time in system. Okay. And we'll just do the same thing here and here. Let's call this record salvage stats. This is the number of salvaged parts. And this is the salvaged time in system. And here we have the scrap record scrap stats. This is the number scrapped. And coordinate system. Okay. And now I did this deliberately to show you that since I used a copy paste and then I moved these modules, it looks like these are connected, but actually they're not connected to anything. So we want to make sure that we delete these old connections and reroute our connections through these record modules. Now, everything here is pretty messy. Nothing's lined up. I do have this arrange toolbar activated so that I can move things around. So I'm just going to take a minute to satisfy my OCD and make this look all nice and pretty. So just give me 1 second. Okay, that looks so much nicer. It has absolutely no effect on the model, but now I feel happy. So I'm just going to hit play again and wait for the simulation to finish. Let's look at the results. So now, in addition to the entity, the queue, and the resource reports that get generated, we also have this user-specified report. And here we see all of the relevant statistics that we wanted to know the answer to. So that's it for this lab. If you have any questions or comments, feel free to email me. I've also created a discussion thread on Carmen, and you can also leave comments here in this YouTube video. So I will see you guys all later.